Good evening, everyone. Today's chapter that we're going to do here is three-dimensional geometry. Till 10th standard, you've learned two-dimensional geometry, where we learn about x and y axis. Here, it is three-dimensional. So we have been dealing with analytical geometry in a plane which contain only x and y axis. But we live in a world where everything is three-dimensional. So we should extend the knowledge of two-dimensional geometry to three-dimensional geometry. So here we will learn the basic concept of three-dimensional geometry. Now we know that in two-dimensional geometry, the given plane is being divided into four parts. The given plane is divided into four parts. So this is a plane is a paper or something which is divided into four parts. And you name them as quadrants. First quadrant, second quadrant, third quadrant, and then the fourth quadrant. Now in a three-dimensional system, apart from this four, x and y axis, yes, we name this as x negative, y positive, and y negative. Now let us assume there is a z-axis. So in a three-dimensional system, there is a z-axis like this, which is standing vertical at that point, at the point where I fixed this. So here, the z-axis will be standing straight. Okay. So it is tough to draw in plane, so we have to draw like this. But it's easy to visualize. If you see the corner of the room, if you're sitting inside a room or a hall or anywhere, just see the corner of the room, just the corner. Two side walls and then the floor. The corner where the two side walls are attached with that of the floor. That is also, you can see a line going like this. So this is x, y, and z axis. So here we are going to learn about this. So as I told you, in two-dimensional, the space is divided into four quadrants. Here in three-dimensional, the given space is divided into 8 parts, which we call it as octants. 8 parts, octants. And in the first octants, x positive, y positive, z is positive. So in the first 4 octants, the xy's nature will be similar to what you see in the quadrant. And z will be positive. So in the first 4 octants, xy's nature will be just like you see in the quadrant, but z will be positive throughout. And in the next 4, that means from 5th, 6th, 7th, 8th octants, xy's nature will be same like the quadrant, but z will be negative. Okay, so octants, the given space is divided into 8 octants. The first 4 octants, the x and y's nature will be just like you see in the quadrant. X positive, y positive, x negative, y positive, x negative, y negative, and then x positive, y negative. But throughout this first 4 octants, z will be positive. And then from 5th onwards, from 5th to 8th, x and y will have the same nature like you had it in the first 4, or just like you had it in the quadrant. Xy positive, x positive, x negative, y positive, x negative, y negative, and x positive, y negative. But z will be negative throughout. So this is how a given space is divided. Now assume there is a point 1, 3, 5. Here x, y, z, all 3 coordinates are positive. So it is plotted in the first quadrant. First octants. The next one, 3, minus 2, 4. X positive, y negative, z positive. So it will be plotted in the fourth octant. Then x negative, y negative, z negative, plotted in the 7th octant. X negative, Y positive, Z negative will be plotted in the sixth octave. So like that, you will know that these points get plotted in the 8 octaves. Then the XOX or XX dash, YOY or YY dash, ZOZ or ZZ dash are three mutually perpendicular straight lines intersecting at a fixed point O as origin. The XOX is x-axis, the YOY dash is y-axis, ZOZ dash is z-axis, and they are called as rectangular axis. The plane containing x and y only will be called as xy plane. A plane containing y and z axis only will be called as yz plane. A plane containing z and x axis, zx plane. And together they are called as coordinate planes. So here are some simple questions based on what you've learned so far. Question number 1. If a point is on y-axis, what are its x and y coordinate? Or let it be, what are its x and z coordinate? If a point is on y-axis, what are its x and z coordinate? If a point is on y-axis, the coordinate will be 0, y, 0. So x and z coordinate is 0 and 0. Question number 2. If a point is on zx plane, what will be its y coordinate? 0. Y coordinate of the plane will be 0. Because any point on zx plane will be x, 0, z. Now, write down the coordinates of the image of -3, 2, 7. Now, -3, 2, 7 lies in the second octant. It lies in the second octant, x negative, y positive and z positive. Now, what are its coordinate in xy plane? The image of the points in xy plane. So, when a question comes like this, the z will remain the z point of that will remain the same. So write down the coordinates of the image -3, 2, 7 in xy plane. So if it is on xy plane, the z coordinate will remain the same. X and y will change its sign. So it's -3 here, it will be 3. 2 here, so it will be -2, and then it's 7, -7. And then for yz plane, it will be, no, it's -7, yeah, 3, -2, 7. -3, 2, 7. Find the coordinates of image of this point in xy plane. If it is xy plane, x and y coordinate will remain the same. Only z will change from the opposite to the opposite form. So here x is -3 will remain the same. Y2 will remain the same. So -3, 2, -7. For the next one, yz plane. So y's coordinate and z coordinate will remain the same, whereas x will become opposite. So it's -3 originally, it will be 3 now. Zx plane. Zx plane means z and x will remain the same. So -3 and 7 remain the same. Y will become -2. So this is the mirror image or image of -3, 2, 7 in the following planes. Now one more question in the same type. What is the image of minus 3 comma 4 comma 7 in YZ plane? YZ means Y and Z coordinate will remain the same. X will become 3. Likewise for the next one, it is ZX plane. So X coordinate minus 7 as it is, Z coordinate minus 1 as it is, but Y will become minus 2. And then XY plane, X is 5, Y is 4, but Z will be 3. So this is the mirror image or image of the point in the following planes. So next, the formulas that we are going to cover under this topic, which is first distance formula, section then, and then midpoint formula. Well, under two-dimensional system, there is only x and y axis. Therefore, the formula used to be concerning only x and y. So it is used to be root over x2 minus x1 the whole square plus y2 minus y1 the whole square. Those who don't know what is distance formula meant for, distance formula is used to find the distance between 2 points, or otherwise length of a line segment joining 2 points. So same thing we do it in three-dimensional geometry, but then apart from x and y, you will have a z also. So x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So same 2 points but in a three-dimensional system. Now, section formula. Now, where and when section formula is used? Section formula is used when a line segment is divided by a point in a given ratio. The ratio is taken as m is to n. When a line segment is divided by a point in a given ratio, we used to use this formula in two-dimensional geometry. M times x2 plus n times x1 by m plus n, comma m times y2 plus n times y1 by m plus n. The same thing, but we'll have a z-axis also. So m times x2 plus n times x1 by m plus n, comma m times y2 plus n times y1 by m plus n, comma m times z2 plus n times z1 by m plus n. This will give us the xyz coordinate of that particular point, which divides it in the ratio of m is to n. And last, midpoint formula. If a line segment is divided by a point in 1:1 ratio, then it is x1 plus x2 by 2, comma y1 plus y2 by 2, the midpoint of the line segment. And here, apart from x and y, you have it for z also. So, the coordinate of the midpoint is x1 plus x2 by 2, comma y1 plus y2 by 2, and z1 plus z2 by 2. So let us do sums based on some of the formulas that I gave you now. The first one is distance between 2 points. So here, find the distance between the following pairs of points. 2 points are given, we just have to find the distance between the 2 points. So simply use the distance formula, root over x2 minus x1 x1 the whole square plus y2 minus y1 the whole square, and yes, plus z2 minus z1 the whole square, plus z2 minus z1 the whole square. Now, it is important to put x1, y1, z1, x2, y2, z2 properly, because sometimes students will make mistake here. So that should not happen. So just use the distance formula between the 2 points. You'll be able to find the distance between the 2 points here. Next one, show that the following points are collinear. Now before that, I'll show you the working of one of the 4 sums. So here, fourth subdivision in the first one, coordinates of A and coordinates B are written. It's been named as x1, y1, z1, x2, y2, z2. Distance between AB, so x2 minus x1 the whole square, that is minus 2 the whole, minus 2 of minus 2, which is minus 4 square. Then 1 minus of minus 1, isn't it? y2 minus y1, so 1 minus of minus 1, which means 2 square, and 3 minus 3, 0 square. So therefore, you get the distance as root 20, which is 2 root 5. Then the next question where we need to prove it's collinear. I read the question already. You need to show that the following points are collinear. So what is collinear? The point lie in a straight line are said to be collinear points. Now then find the distance between A and B. Find the distance between AB. Find the distance between BC. Find the distance between AC. Distance AB is root 14. Distance BC is root 56. Distance CA is root 126. Root 14, there is no further splitting in that. Root 56, we can write it as 2 root 14. And root 126 is a 3 root 14. So AC equals to BC plus AB. So with that we prove that the following points are collinear. Alright. Third question, we have to prove that the following is an isosceles triangle. Verify whether the following points forms a right isosceles triangle, right angle triangle, and then a parallelogram. Well, find the distance for all the three, like distance AB, distance BC, and distance CA. Before that, name the points as A, B, and C, or as you want. Find the distance between AB, BC, and AC. If any two distance out of the three are equal, then it's an isosceles triangle. So if any two sides are equal, then it's an isosceles triangle. The third one, it's a right angle triangle. So find the distance between three sides, length of three sides, and use Pythagoras theorem. Parallelogram, opposite sides are equal. So here we cannot use the slope formula, so you have to use the distance formula. So find the distance between AB, BC, CA and AD. AB, BC, CA and AD. If any two of them, if opposite sides distance is equal, then it's a parallelogram. Now, fourth and fifth are important questions. Find the equation of set of points which are equidistant from these 2 points. Now there is a set of points which moves in such a way that it is at equidistance from these 2 points. Alright, equidistant from these 2 points. Let's see how to do that. Now here, point A, this is question number 4. Point A and point B is given as in the question. P is a point which is considered as a point which is at equidistant from A and B. As per the question, PA equal to PB. So PA square equals to PB square, right? Avoiding the root so that you can easily solve it. So square on both sides, so you get rid of the root. Now use distance formula for P and A. So your x1, y1, z1 is this, and x2, y2, z2 is this. So x minus 1 the whole square, y minus 2 the whole square, z minus 3 the whole square. So you get like this. And then what? X minus 3 the whole square, y minus 2 the whole square, z plus 1 the whole square. So you get it like this. Then every term is expanded using a minus b and a plus b the whole square formula, depending on which form it is. Here it is a minus b the whole square formula. So x square minus 2x plus 1. Here also a minus b the whole square formula. So y square minus 4x plus 4. Here also a minus b the whole square. So z square minus 6z plus 9. Like that on the right side also. Then simplify the given expression. You will get the equation of the set of points which are equidistant from these 2 points. R is in the form of x minus 2z equal to 0. Next question. Let's see the question first. Find the equation of set of points whose sum of whose distance from these 2 points is 10 units. So as per the question, there is point A and point B, but P is in such a way that PA plus PB equals to 10 units. So PA plus PB equals to 10 units. Take one of the term to the other side, either PA or PB. Then square on both sides. So you come to this step. Squaring on both sides, one side will be PA square, another side will be 10 minus pb the whole square. Don't make a mistake of writing it as 10 square minus pb square. So when you square on both sides, you get a whole square there. So keep in mind. Now 10 minus pb the whole square is 10 square, pb square minus 20 into pb, a minus b the whole square formula. Then p is x comma y comma z that we assumed, and a is a given point. Take distance formula, but now I'm not putting root because there is a square. So you get this. pb, again distance formula, you get this. pb square, therefore no root. Whereas here pb without square, therefore this will come with root. So do not disturb this, keep it as it is. Simplify the rest of the term as much as possible. So once I simplify, I come to this point. I'm asked to find the equation here. I'm not in the form of equation right now, so I need to square it one more time. But before I square it, I just want to know whether it can be simplified further. Yes, of course, I can take 4 common out from this. So the 4 get cancelled with 20, so 5 remaining. So eventually I'm getting 5 times root over this equals 4x plus 25. Now square it once again. This sum is pretty long. Make sure you don't make any mistake while expanding, because one term mistake will cost you another 15 minutes. So make sure you don't make mistake here. So squaring it one more time. So here root will get cancelled, 5 will become 25, and 4x plus 25 the whole square. A plus b the whole square formula on the right side. Left side, just multiply the expression with 25. Simplify further on. You will get this as your equation of set of points such a way the sum of whose distance from A and B is equals to 10 unit. So this is the first video on three-dimensional geometry. Hope you understood the concept better. Remember, 11th three-dimensional geometry is very, very simple. So let the basics be strong. Thank you.